series. I'm going to ask if you're not one of the speakers to please make sure you stay muted and keep the video off. We do want to have that feature available to people if we get time for questions at the end. So we'll just kick it off. Like I said before, this is the first episode of our series, Facing Challenges of IT Transformation within METOC. Some of you know what METOC is, but for those of you that do not, METOC stands for Meteorology and Oceanography, and it's generally used in the context of supporting operational missions. I'm Paul Williams, Vice President of CONIAG Government Services. I have more than 20 years of experience of bringing enterprise systems to the federal government. I also have about a decade of experience working with METOC systems for the Navy. Today, we have a panel of experts with a diverse background. They will be talking about some of the specifics of operational and technological METOC solutions. So I'll start off with Chris Strager. Chris Strager is a retired senior executive with the National Weather Service. His last position was director of the agency's Central Region. He also has 30 years as an Air Force veteran who served as the commander for the 146th Weather Flight, providing tailored METOC products to special operations customers. We also have Dan Lane. He's a director over our FBI programs at CONIAG Government Services. He also serves in the Air National Guard as the commander for the 146th Weather Flight. We have Brian Smitches from AWS. Brian knows everything about cloud. He is solutions architect with AWS and supports us across our customer base at CONIAG Government Services. And we also have, last but not least, Zach Curtis. He is a senior solutions architect with CONIAG Government Services. He is driving the adoption of generative AI, both internally at CONIAG Government Services, as well as with our clients. So now that we've got introductions out of the way, let's just jump right in. METOC leverages IT as an enabler to build products that help decision makers quickly assess the impacts of weather on their mission. The METOC community faces many enterprise-level challenges with their IT systems, including legacy systems that need to be upgraded, data silos and interoperability within and outside of the community, cybersecurity threats, resource constraints, such as limited budgets or a lack of technical staff, and then directives, like directives to move to the cloud. As do most missions, METOC relies heavily on data and has more of it than many of the organizations within the federal government. They also have a lot of special use cases like supporting models, disconnected operations, and the use of special equipment such as satellite feeds and precise time instruments. We're going to talk through some scenarios today, but would love to have your questions and feedback. We'll try to address them during the session. If not, we will follow up. But it will also help shape what our future sessions will look like. So if you have the questions, please post them in chat, and we'll get to them if we can. Okay, Chris, we're going to start with you today. We're going to hear a lot about AI during this discussion. It's such a hot topic in industry right now. Can you tell us a little bit about the differences in using AI for weather versus using traditional modeling?
Yeah, sure, Paul. Thank you very much, and good afternoon, everyone. Again, I'm Chris Strager, and it's great to be with you all here today. And Paul, as you said, that has been a big topic over the past, I'll say, 6 months or so in the IT and METOC world, is basically what is AI's ability to produce meteorological forecasts. I think Google DeepMind's GraphCast is the one that I've heard of several times over the past few months. These are really exciting times for the science of meteorology. There have been some incredible advances since I started back in 1978. The question I'm hearing from meteorologists today is basically, what is the outlook for the human in the loop and AI-produced forecasts, and where will the forecaster fit into the customer's decision-making process? To really understand this question, and let's back up just a little bit and look at what AI generated forecasts are and how they compare to traditional forecast methods. Now, numerical forecast models rely on complex computing systems, working with the basic equations of motion. It takes several hours to produce output, and they also produce a tremendous amount of data points. AI, however, can generate forecasts much faster on a scale of a few minutes using far less computing power. AI basically is relying on over 4 decades of previous events based on statistical models. The keywords here are pattern recognition. Now, pattern recognition in meteorology is really nothing new. Dr. Irving Crick was using these techniques back in World War II to help produce the D-Day forecast. Dr. Crick turned this method of pattern recognition into a very successful private company that continues into this century. He used pattern recognition to produce forecasts out to and beyond 9 months for retailers and other customers. Of course, now computers can perform this task with incredible speed and accuracy, much better than any human can do. But there are significant differences between forecasts produced using AI and traditional numerical modeling methods. I guess a big one is that numerical models can be examined after the fact to see why the forecast didn't verify and to correct. I think a great example of this was probably Hurricane Sandy back in October of 2012. The European model was the first to hint at the left turn of Sandy into the east coast of the US. Post-event analysis by researchers and scientists saw what the European model picked up. Changes were made to the US models, and hopefully we are now set to better forecast something like this in the future. And I'll say not if it happens again, but probably when it happens again. AI, on the other hand, operates in more of a black box environment. The user is going to see the output, of course, but doesn't really know how AI arrived at that solution. Since AI forecasts rely on past events, it's pretty much not likely to forecast a record event. An example of this would have been Hurricane Harvey back in 2017, when 60 inches of rain fell along the Texas coast. The numerical forecast models and the forecasters eventually caught up with it, with what this storm was doing in the precipitation amounts. But since AI is based on past events, I really don't know how likely it would have been that AI would have produced 60 inches of rain along the Texas coast. However, events like Harvey and those record-breaking events are the ones that are really critical to EMs and military planners. Another significant difference between AI-produced forecasts and numerical models is that AI only produces a single deterministic forecast, while numerical models now capable of producing and quantifying the uncertainty of a forecast. I think all forecasters would like to say, well, we're 100% certain, but we know that's not the case. And being able to articulate the uncertainty of a critical forecast is really important to the decision makers. Now, AI-produced forecasts are striving to produce more than a deterministic forecast. They're not there yet, but again, I'm anxious to see over the coming years how far they progress in that category. Paul, I suppose the final point I have regarding AI-produced forecasts in the human in the loop, AI is another tool in the meteorologist's toolbox and really brings some exciting possibilities for the future. But a meteorologist that is knowledgeable of the customer's mission and their critical thresholds will still be needed to work alongside customers to assimilate this information and assist them in making those critical go and no-go decisions. And Paul, with that, I think I'll turn it back to you.
All right. Thanks, Chris. Chris, you've got a lot of experience with both the civilian side as well as the defense side of weather. And over the years, like, what are one of your favorite technologies that you've seen in your practice?
Wow, there have been so many. Doppler radar would probably be one of the things, but I think I'd probably have to go back some of the points that I just mentioned. The numerical models have just been amazing in what they've been able to do. When I started in 1978, we had the LFM out to 48 hours on die-fax paper. We thought that was pretty good stuff. We didn't trust that NGM when it came out because we knew the old methods. I look now at forecasts out 384 hours on the GFS, 16 days. And yeah, I get it. You take it with a grain of salt when it goes out to 16 days, but it's a trend. You can watch the trends. If your customer has a significant event coming up in the future, you can watch how the forecast models are trending and advise the customer that. That goes back to the human in the loop again. And you can slice and dice the models now. We can go up potential temperature surfaces. I can take cross sections at any hour. Just amazing things that we're able to do now. And I think I could probably take up the rest of the talk, but I'll constrain myself and turn it back to you.
Thank you. And thank you for your service. Okay, now we're going to turn our attention to Dan. Dan, you're supporting operations today. What about some of your insights into the technology that you use?
Thanks, Paul, for the introduction. And as Paul stated, I'm an Air Force weather officer and an IT program manager in my civilian career. So this topic's pretty close to home for me. So from my perspective, I've watched as technology shifted and played a major changing role in a forecaster's ability to accurately predict phenomena in a timely manner. But it's about the amount of data that's available to a forecaster now, and it's quite overwhelming. So, a typical forecaster is required to take and conduct analysis on multiple products, from satellite photos, radar, upper air soundings, surface observations, and the model data itself, and then typically take that from and narrow their forecast from what we call macro scale. So maybe a few hundred miles or thousands of miles down to like a micro scale forecast, covering a few miles, or like a point forecast in the field to put an aircraft on the ground. And so this is a lengthy process to analyze these products and verify, correlate, and then produce a meaningful forecast that's going to have an impact on the mission. So these forecasts, of course, and they're going to be prone to human error, like Chris mentioned, and the forecaster is about as good as the data at their disposal, right? So there's a degree of wrong that they might be, and then there's a degree of wrong off of the data that's wrong. But one of the most common proven tools, as Chris also mentioned, is that trend analysis piece, and it's a learned, like through experience, forecasting for a region, and it relies heavily on a forecaster's attention to detail and really understanding like local geographic effects on the weather phenomena. So that experience, of course, it takes time and it comes with failures. And trust me, like Chris mentioned, we've all blown a forecast or two. But that trend analysis requires sifting through and cataloging large quantities of data to recognize patterns, right? And then this is where that AI and ML really plays a part and comes in, right? Cutting edge technologies like AI and ML can improve the accuracy and the speed of the forecast. And so using these tools to ingest large data sets and analyze those patterns and allow forecasters time to focus on making focus on that model interpretation piece and like finessing the delivery of complex information to those decision makers is the most impactful way for us to combine those tools. And so there's this piece of this called the so what, right? So the forecast, the model produces something, and then there's the so what, which is like, why does a commander care about what we're telling him? So, or her, and the so what is like, what's the relevancy of the weather on an operation or the impacts? And so a mission commander, is not necessarily interested in the fact that, the forecasted high temperature is 38 degrees Celsius, but they care more about the impact of that temperature on work rest cycles of troops in the field or even an aircraft and the fuel load that they carry, right? Because it can affect the air density, and therefore decreased fuel load could decrease the amount of equipment or people that an aircraft carries, or even the loiter time that an aircraft's in the sky, providing some kind of surveillance or reconnaissance. So there's a lot of impacts about like one specific category of weather. And in understanding that, our meteorologists, we equip the leadership with the information necessary to make informed decisions and ultimately assume that risk of a go, no go in an operation. So really in closing, by having AI and ML at our disposal, that those tools can do the more laborious and time consuming tasks. And the forecaster has access to a more accurate picture quickly. And then they spend their valuable time on analysis of risks and the impacts of the mission, which will increase the odds of success. So, thanks, Paul, for the opportunity to provide my input on this extremely interesting topic.
Yeah, thank you. I appreciate you being here. So you have to plan deployments with your troops. What is one of the things that you don't have in your toolbox that you would like to have from a technology perspective?
So that's a good question. So in something I didn't really touch on that has a significant impact on remote operations is that consistency of network access, quality, and speed. And typically we don't have a dedicated way of getting that data. So for meteorologists, that lack of access to the internet or weather products severely degrades our ability to bring value to the fight. So in summary, like tactical and global connectivity would be at the top of my list.
I think that makes good sense. So now we're going to turn it over to Brian. Brian, maybe you have a couple of solutions from AWS that could help with some of those.
Thanks, Paul. Yeah, so to Dan's point, for the forecasters, analysts, and operators in the field, access to technology is immensely critical for these people to be able to do their jobs, which directly influences the success of the mission. Technology is known to increase speed and accuracy of some of these forecasts, which has a direct impact on what decisions are made. So when thinking about mission operations in the field, a common question is, are we even able to leverage cloud, given the traditional challenges that we faced at the tactical edge, such as Dan's mentioned network connectivity? Because at the tactical edge, the internet and cloud constraints are present, AWS uses a term that we call the denied, disrupted, intermittent, and limited network environments to talk about these types of circumstances. So DDIL for short, denied, disrupted, intermittent, and limited network connectivity. Just because you operate in one of those DDIL environments, it actually does not preclude you from being able to use AWS products and services to support your mission. So these missions at the edge are increasingly considering how cloud capabilities can support their needs and requirements. And once they're able to get access to those innovations that come from AWS and the open source community, they realize the benefits to help impact the success. Some sample paradigms of how people are using cloud at the tactical edge include edge compute. So AWS has a product offering called the Snowball Edge device, which is about the size of a suitcase, and it offers completely offline local compute and storage where you can run your virtual servers. And this is a device vended by AWS. It's portable. And so because you're able to run your processes out in the field, you don't need to connect to any AWS data centers around the world to be able to leverage those cloud technologies there. And then another example, more towards Dan's challenge that he presented, is that access to the internet is not traditionally available. And so improving network access connectivity in the field for the warfighter will have a significantly positive impact. AWS and Amazon have Project Kuiper, which is helping relieve network constraints through establishing connectivity via satellites. And AWS has a blog that's public that you can all go Google to see how the DoD is working with AWS to be able to establish hybrid cloud connectivity through Project Kuiper and the satellites there. And then a third trend is because of that network connectivity, we're starting to see more hybrid cloud operations rather than strictly edge operations. So the question becomes, what can you run in the cloud? Because if you can run it in the cloud, then you probably should run it in the cloud. And we have that hybrid approach where the parts of the workflow that can tolerate interruption is where that transition happens from the cloud to the edge. So an example of this would be if you're creating software artifacts. The creation of those artifacts can happen all in the cloud seamlessly for developers or whomever, but then the delivery of those software artifacts as a part of the pipeline can be the point where you transition from the cloud to the edge. And then another question that's considered when you're talking about hybrid cloud is the data that's generated in the field easily transported to the cloud? If it is, and we can use satellite connectivity or existing network connectivity, if that bandwidth is enough, considering the density of the data that's being generated, then great, we can still use the cloud capabilities, assuming that the latency is tolerable. And then if not, let's figure out what processing we can do at the edge with some of these edge devices so that we can still get some benefits of the cloud while managing the hybrid establishment. When looking at the cloud, you get benefits such as on-demand capacity, specialized hardware, and purpose-built surface offerings. And then on the edge side, of course, you get everything's local and close to the edge for your immediate operations. In the cloud environments that are hybrid, some of the domains that functions in include data lakes, machine learning operations, DevSec operations, DevSecOps, disaster recovery, and the ever popular field of generative AI. And then for the METOC community, we're thinking about forecasting models, right? Is there a chance that we can take some of these forecasting models, take a lightweight version of them, deploy them in the field to run the inference locally? And then we can figure out how we're using cloud to generate those models along the chain. So in summary, AWS is, of course, investing in innovation that can support the warfighter and the METOC community's missions. And we need to have conversations with everyone to find out what your requirements are. And when it's time to get to work, we recommend working with a partners such as CONIAG, who is very capable and has supported DoD and federal agencies all around to get access to cloud, to extract value, and serve on missions. So with that, I'd like to give it back to you, Paul, so we can hear some more from CONIAG about how AI is impacting this space.
I appreciate that. And thanks for the endorsement, Brian. We are really excited to see what Kuiper looks like. You know, we've had some great success with the edge devices deploying to the field in those bandwidth limited situations, right? So, all right, now we'll move on to Zach. Zach's going to tell us a little bit about how AI can be adopted by the METOC community.
Thank you, Paul, and good afternoon, everyone. I just want to kick off by kind of level setting a little bit to say there's actually many different types of artificial intelligence, robotics, machine learning, natural language processing, just to name a few. But today I wanted to focus on foundational models and the use cases we can solve, in particular, large language models and computer vision models. Now, one of the use cases that we've been working with that's really been quite exciting to me is deriving structured data from unstructured data in an automated fashion using AI. So that's to say, we can define a schema of what information that we're interested in and pair that to the model with documents such as Word docs, PDFs, any kind of text documents, and have the model extract whatever information we desire from those elements. From there, we can put that into a like a data mesh or a data lake. And if you can just imagine the incredible value that provides, allowing us to run advanced analysis, you know, derive key insights, track trends over time, like Dan was talking about. And one of the really interesting things is we can think outside the box a little bit, in that we can leverage the language model to actually help us uncover hidden insights. So there actually might be key information within our data set that we didn't consider as humans to even look for that exists, and the LLM can help us identify that. Chris mentioned that, you know, AI is a little bit of a black box, and that's definitely true. We don't necessarily fully understand often how it arrives at a specific outcome. But one thing we can do to mitigate that and to help us understand is to leverage cross-referencing techniques. And basically that allows us to track what documents, what data sets were used in the logic chain, and actually provide, say, citations to the user. So when we have a chat with our documents, we can actually have it point to a specific line that it used to derive a specific answer. Another use case is leveraging computer vision models for processing video and images. So they can actually identify people, objects, and even activities or actions taking place. And that can come from satellite imagery, aerial photography, or even mission photographs. We use it internally to generate code, so we can identify within the model let it know what feature that we're trying to build and what language we're wanting to use. And it can actually generate boilerplate code that's often pretty good code that we can then modify for our own needs. We can also use it to refactor legacy code, so it can understand archaic languages, and we can ask it to convert it into modern languages and modern techniques. I particularly love, as a developer, I hate writing unit tests, and so we can actually pair the model with our code and have it automatically generate unit tests and the data that is required to test those elements as well. It's really nice because it often will have more complete tests that find scenarios, failure scenarios that as a developer we probably wouldn't have found. So these models have gotten really powerful, but they've also gotten very efficient. So we can actually fine tune models for a specific task and deploy those at the edge into the field running on local machines, and even in a disconnected state, to what Brian was talking about. We're always focused within that, though, on security, risk mitigation, and privacy. So there's services like AWS's Bedrock or SageMaker. It's really cool because we can actually deploy that into a private cloud environment so that users can interact with that model using proprietary data without that information ever even going over the internet. So totally isolated. The best way to really think about AI, specifically generative AI, is to imagine you have 500 unpaid college-educated interns, and you should trust it at that level. So would you trust an intern to make a significant tactical decision in the field? Probably not. But might an intern be trusted to generate the first draft of a speech you're going to give? Sure, that seems reasonable. Ultimately, the goal is always to allow personnel to really focus on high-value activities. So getting them away from the laborious and repetitive tasks and focusing on their skill sets and leveraging that to produce value. And with that, I hand it back to you, Paul.
All right, thank you. I appreciate that. I was on a pretty interesting presentation yesterday watching where the government was moving their mainframes to the cloud using AI for generating all the code to move from the old COBOL into something more modern like Java. So
yeah, absolutely.
It really can make quite a bit of difference. So that is what we're going to hear from our panelists today. I thank you all for coming. It's apparent that you're all experts in your field, and we appreciate it. This is the start of our series. Our next one is going to be a really exciting topic, and it's going to dive a lot deeper in AI. So we'll be talking about how to set up a AI Center of Excellence in the government for our next one. So if you want to learn more about AI, how to properly use it, how to ethically use it, and some of the technologies and frameworks around doing that, then tune in for next time. We'll send out the invite, and we're targeting about a month from now. So we look forward to having you all again. If you do have questions, you can contact us at growth@coniag-gs.com. And we look forward to hearing more from you. Are there any questions that anyone has now that they would like to discuss? Thank you, Rebecca. Okay, well, thank you everyone for coming, and we look forward to seeing you in a month.
Thanks, everyone.